Hello everyone, welcome back to my channel. In today's video, we are going to design and understand a complete production level architecture using Amazon ECS service with Fargate. This is not a theory video. This is exactly how real companies deploy containerized application on AWS. We will start from the network foundation and slowly move all the way to CI/CD monitoring. So by the end of this video, you will have a clear understanding how an application actually run in production on ECS Fargate. So currently my account got suspended of AWS. That's why today I'm not going to show you the practical thing, but I will explain the architecture. And trust me, if you understand the architecture, then only you can implement in AWS itself. Without understanding this, it's really difficult for you guys to understand all these things. So without further delay, let's start. I hope my screen is visible to you all. So yeah, why do company prefer ECS with Fargate instead of managing EC2 instances? So this is the question first came in our mind. So by seeing this diagram, we will get to know what this video is all about. And don't worry, I will explain all these things here. It have been written like I am going to explain from the ground level and how design deploy application infrastructure using ECS with Fargate in real production. Exact way it is done in the companies, not just theory but practical architecture also. So this diagram, so this diagram represent the high level overview of how Amazon ECS services with Fargate work in real production environment. So first, let us understand what are seeing here before jumping into the implementation. At the top, we have user or client. If you will see, this is user or client who are accessing our application through the internet. Okay, for example, this is our application, so they are accessing from where? From the internet. These users can be browser, correct, mobile application or external system also, and they request, so anything will be our user. So their request first will reach where? That if they are trying to access, so first it will go to the, if anyone is trying to access, so first it will go to the application load balancer, okay, which act as a single entry point to our application. So single entry point is what? Application load balancer. Okay, now if the people will ask what is the reason, so the reason we use as a load balancer instead of exposing container directly is because container are ephemeral and can scale up and scale down dynamically. Ephemeral means it will be automatically scale up and scale down. So now behind the load balancer we have ECS services which are responsible for mainly the desired number of running container. So ECS services is responsible for the desired number of ECS services. Okay, I hope you are understanding. Again, I'm explaining, behind the load balancer we have ECS services. Okay, what it actually do, that ECS are responsible for maintaining the desired number of running container. So these services run tasks on Fargate, and the Fargate is the key component here because it removes the need for us to manage the ECS EC2 instance under the AWS component, like AWS component. Why? Because it automatically provision compute capacity, networking interface, and isolation for each task as a DevOps engineer. So we only define how much CPU and memory the container needs, what image to run, and how it we can say that it should scale. The diagram also show Amazon ECR which store a Docker image, and ECS never pulls code directly from GitHub. It always pulls container inside from ECR, and this ensures immutable deployment where the same image now runs across environment. So the VPC boundary shown in the diagram represents network isolation. So everything include load balancer, ECS task, and supporting services run into a where control network. So IAM roles are attached to task which decide what AWS services the application can access, and CloudWatch is integrated for the log and metrics. So whenever you look at this environment diagram, so it tells a complete story of request flow, deployment, scaling, security, and monitoring in one picture. And this is exactly how modern companies design container platform on AWS. Okay, so see, this is the user. Whenever they are trying to access, let me explain in short. They will go to the application load balancer. Behind the load balancer, there is a ECS which will decide the number of the container running. This is inside a VPC. Okay, now once it will come, it will go to the AWS Fargate. Here it will search list and everything it will happen. Now after that it will go to the AWS system manager. Okay, this will take, and here elastic for Redis, this is private, inside the private subnet. This is the databases like RDS or Elastic Redis. These are to the databases, and this is the CloudWatch. Here we can do monitoring. Now in simple, here see, internet it is coming. It is coming to the internet gateway. There, this is the reason, whatever the reason it will be there. Inside that reason there is a two subnet, public, both are public subnet, and here both are private subnet. Here it is launching by taking Fargate launch. After that CloudWatch logs and DynamoDB ECR. So this is the full application which we are talking about. Now let's move to the modern DevOps code. Okay, I know like this one is very high standard way I have explained, but don't worry, I will explain each and every component in detail also. But as of now, just understand whatever I have told, and if you're not understanding, then also it's fine. Just try to see it again. So this diagram, the main goal is to not just to run application. So this diagram explain why ECS Fargate is relevant in modern DevOps. Because traditionally development and operational worked separately, which causes delayed failure and manual intervention. But in the modern DevOps, the goal is continuous integration, continuous deployment, automation, monitoring, and fast feedback in the life cycle. Developers push the code frequently. So CI pipeline automatically build and test the code. Now container are created using Docker, and these images are stored in the registry like ECR, and then CD pipeline deploy these images to a platform like ECS Fargate, and then Fargate first perfectly here Fargate perfectly fit here, and because it removes infrastructure bottleneck, teams do not wait for the server, do not manage scaling manually, and do not worry about capacity planning, and after deployment monitoring, the logging came into the play. So metrics are continuously observed using CloudWatch. So alerts are triggered automatically, and feedback loops help team to improve application performance and reliability. So this diagram also highlight collaboration, automation, and repeatedly which are application performance and reliability. So this will highlight collaboration, automation, and repeatedly, which are the core DevOps principles. So ECS Fargate supports this life cycle by being fully managed, scalable, and deeply integrated with AWS services, making it ideal for CI/CD driven environment. So this is total seven CS of DevOps: continuous development, integration, continuous integration, continuous testing, continuous deployment or delivery, continuous feedback, and continuous monitoring, and continuous operation. Okay. Now the third question is why? Why ECS with Fargate? So this diagram, if we will, let me increase the font. Why ECS with Fargate? So this is the ECS, here EC2, and this one is Fargate. So in EC2, auto scaling group is there. So task 1, task 2, container instances, and this is the container instance. In AWS, task 1, task 2, task 3, task 4, task. So here no need to maintain container instance. Now this diagram represent ECS running on EC2 versus ECS running on Fargate. And this comparison is extremely important for interview and real world decision. So on the EC2 side, if you will see, you can see that the teams must manage instance type, auto scaling group, EMI patching, disk capacity, and failure recovery, which are increase operational overhead. And on the other side, if you will see, so other side, all these responsibilities are handled by AWS, and there are no EC2 instances visible to the user. So no auto scaling group to configure, no patching responsibilities will be there. Billing also changes significantly, and with EC2 you pay for running instances whether container are using full capacity or not. But with the Fargate, you pay only for CPU and memory allocated to running tasks. Security, isolation is also a stronger in Fargate, because each task run in its own isolation environment, and making it safer for multi-tenant workloads. Scalability becomes simpler because Fargate automatically scales compute resources with tasks, and this diagram clearly shows why modern production system prefer Fargate unless there is a very specific need for EC2 control. Now, next step is what serverless means here. So we have two diagram. Like this full project I will cover in 3 days. So today is day first, tomorrow and day after tomorrow. In these 3 days I will explain this to you guys. Now here if you will see that we have two diagram, and what serverless means here. So this diagram represent the virtual private cloud known as Amazon Virtual Private Cloud. Okay, so which is the foundation of any production grade infrastructure on AWS, because before deploying containers, database, or load balancer, we must first design a secure and isolate network. So a VPC is essentially logically isolated section of AWS cloud, where we define our own IP address range in using CIDR block containing routing, and decide how resources communicate with each other. So in real project we never deploy application in the default VPC, because it's lack proper segmentation and security control. Instead we create a custom VPC where we explicitly define subnet, route table, and gateway, and secure security boundaries. So this diagram usually show a VPC speed across multiple availability zone, which is critical for high availability and fault tolerance. In one availability zone, or we can say is AZ zone goes down, our application should still accessing from another zone inside the VPC. All the component like the load balancer, ECS task, net gateway, and database live together but remain isolated from the public internet unless explicitly allowed. The isolation gives us full control over traffic flow, security policies, and compliance requirement. And from an interview perspective, you should always remember that the VPC is not optional in production. It is backbone that ensure networking security and scalability for ECS Fargate deployment. So hope you understand now. And you guys, if you have any doubt, please ask in the comment box, or you can ask in my Telegram channel. Telegram link is already there in my YouTube profile. So moving to the next, public and private subnet design. So this diagram explains how we decide a VPC into public and private subnet, which is one of the most important concept in AWS networking. And a subnet is simply a smaller network inside a VPC. And in production environment, we always create multiple subnet across different AZ zones. Public subnet are those that have a route to the internet gateway, meaning resource inside can directly communicate with the that route to resource can directly communicate with that internet. And private subnet on the other hand do not have direct internet access, and this separation is done mainly for security reason. So in ECS Fargate architecture, we also place the application load balancer in public subnet because it must receive traffic from users over the internet, but ECS tasks are placed inside private what we can say private subnet, because the application container should never be exposed directly to the external traffic. So instead, all traffic should flow through the load balancer. This design protects application from direct attack and allow centralized traffic management, logging, and TLS termination. So this diagram also usually shows multiple public and private subnet across availability zones, and which ensure that even if one zone fails, the application continuously to run. And this public private subnet separation is considered as a mandatory best practices in real enterprise architecture. Just give me 1 minute. Sorry for the inconvenient. Yeah, now why VPC is important. So this gateway is like, this is explaining why it is important, and it is explaining internet gateway and net gateway flow. So I think this question is similar, why it is important, so we better to skip it. Yeah, now this one, public and private subnet, and the flow diagram is also there with us. So this diagram rules of public subnet, if you are talking about, and private subnet. So this diagram focus on the role of public subnet in ECS Fargate architecture, and the most important thing to understand here is that in a secure production environment, only very limited component are allowed to live inside a public subnet, and the most common and recommended component is the application load balancer. The public subnet is configured with a route to the internet gateway, which means any resource placed inside the subnet can directly communicate with the internet. And the reason we place the application load balancer here is because it is the entry point for all the user traffic, whether that traffic comes from a browser, mobile application, or external system. The load balancer listed on the ports like 80 or 443 and terminate incoming connections. So in many real world system, https termination also happens at the load balancer level when simplified certification management. And another important responsibility of the load balancer shown in the diagram is traffic distribution. Because ECS tasks are dynamically and can scale up and scale down at any time, the application load balancer continuously keeps track of healthy target and forward traffic only to container that are healthy. Hits different ensures that even if one container crashes or becomes unhealthy, users are not attached. From a security perspective, the public subnet should be tightly controlled using security group and network ACLs. And so no backbone services like ECS, task or database should ever be placed here. So when you explain this diagram, the in the like in the interview, so for example, if you want to show the diagram or making by showing some dashboard and you want to show, so always use public subnet exist mainly to expose control entry points and like the load balancer and nothing else. Don't make it too complicated whenever you will explain in the interview. Now, roles of public subnet. So here it is coming from the internet will go to the internet gateway, then it will go to the route table. With the route table it will go to the, now here it's come, so after coming to the route table it will go to the application load balancer. From there it will go to some to the public subnet. From there it will again go to the private subnet, and here also route table will be there. And this is the diagram. Public subnet are used only for the component that most exposed to the internet, and mainly the application load balancer which receives traffic from the users. Now roles of private subnet. So I will explain it in more depth little bit. So this total diagram that will explain the purpose of private subnet, which is where the actual application workload lives. So in ECS Fargate architecture, all ECS tasks are launched inside the private subnet. Why? To ensure that the application container are completely isolated directly from the internet access. And private subnet do not have a route to the internet gateway, which means no external user can directly connect to the resource inside them. Instead of all the traffic must pass through an application load balancer, and this design dramatically improves security, reducing the attack surface. Another important point shown in this diagram is that even though the private subnet resources cannot receive inbound internet traffic, they can still initiate outbound connections through the net gateway. And this allow ECS tasks to pull Docker image from ECR, connect to the external APIs, or send telemetry data. So in production, environment, private subnet are also where we deploy database internal services, and the background works keeping them protected from the public exposure. When explaining this diagram in the interview, please make it is important to highlight that private subnet are the backbone of security in the cloud architecture, and that placing application workload in the private subnet is considered as a non-negotiable best practices. But I will suggest don't go with the diagram in the interview, just explain in a simple way. Okay. And in this diagram also I want to explain ECS Fargate inside private subnet. So this diagram zooms into how ECS, if you'll zoom it, so it will show you how ECS Fargate task actually run inside a private subnet. and each Fargate task get in own elastic network interface. If you will see elastic network interface. Now network interface, also known as a ENI, which means every task receives its own private IP address from the subnet. And this is very important concept because it allow the application load balancer to route traffic directly to individual task using IP based target group. So unlike traditional EC2 based architecture where multiple containers share a single instance network interface, Fargate provides stronger network isolation between tasks. Another key point shown here is that security group are attracted attached directly to the through the internet, what we can say, uh, that what is this ENI. So giving very granular control over inbound and outbound traffic. And at the container level, this allow DevOps team to restrict access so that tasks only accept traffic from the load balancer and nothing else. So this diagram also represent how tasks communicate with AWS services such as ECR, CloudWatch, Security Manager through the secure AWS networking. And because these tasks are running inside private subnet, even if someone known the IP address of a task, they cannot access it directly from the internet. This architecture greatly improves both security and observability. And when you explain this in interview, but I will not suggest to explain in the interview. So yeah, that's it. Now let's move to the internet gateway, and this is the last topic for today's videos. So this is very important. So this explain the role of the internet gateway in AWS network, and this is a very important concept to understand before moving further. The internet gateway is horizontally scaled. It means that will be highly component that it attached to a VPC and enables communication between resources inside the VPC and the public subnet. So without an internet gateway, no resource inside a VPC can directly send or receive traffic from the internet. So in ECS Fargate architecture, the internet gateway is primarily used by resource in public subnet, especially the application load balancer. So when a user sends a request from a browser, the request first travels through the internet and reaches the internet gateway. From these, from there, it is routed to the load balancer based on the route table configuration. This is why public subnet also have a route like 0.0.0/0, pointing to the internet gateway. Another important thing to understand from this diagram is that internet gateway itself does not expose private subnet resources. It allow traffic to reach resources that are explicitly placed in the public subnet and have a public facing configuration. This means that even though the VPC is connected to the internet, private subnet mainly fully protected in that. So in interview, you should always remember to mention that the internet gateway is mandatory for any internet facing architecture, and that it work together with the route table to traffic flow, and in production environment are tightly integrated, which resources can use the internet gateway. So that's it for today's. Thank you for watching Study with Varsha. Have a great day. Please like, subscribe and share with your friends if they want, and have a good day.